Cells, often known as the building blocks of life, are the basic structural, functional, and biological units of all known living organisms. And yet, these microscopic structures are able to reach levels of incredible complexity. In this video, I will talk about the novel way to model in vitro cell-to-cell mechanical interactions. Further details about this model can be found in the original source, Magnetic Approaches to the Study of Collective Three-Dimensional Cell Mechanics in Long-Term Cultures. Mechanical stresses generated between cells and their surrounding ECM are critical for cell adhesion, function, and tissue development. These stresses are modulated both by contrary forces generated by the cells and by the stiffness of the ECM that opposes those forces. Many current models attempt to describe this process via 2D substrates. However, these models are unsuited to address the broader field of tissue remodeling and morphogenesis, since they are unable to take into account both the contractile forces and the stiffness of the ECM at the same time, making them lack the complexity to model reorganization and the deformation that occur at a 3D level. Now we're going to be going in a bit more detail into the article. The approach taken is the use of elastomeric cantilevers embedded within a 3D collagen microgel to quantify the forces during the cell-mediated contraction of the collagen matrix into a line microtissue band and a simple model to begin to understand the mechanisms of tissue contraction and formation. Furthermore, integrating the microdevices via a magnetic activation system, as we see in this picture right here, allow to apply external loadings in individual microtissues. Using this MMT system, you can decouple stiffness and contraction forces of microtissues for short periods of time. However, this type of tissues require a relatively long culture period to interact with the surrounding mechanical environment and reach maturity. Therefore, it was needed to see if the MMT system could be used to accommodate various mechanosensitive cell types during long periods of time. Now, the article goes a lot into detail about how they use spontaneous stress equations such as these, or this shear stress that we all know for several area, or even a lot more in detail into how they use the magnetic fields to produce the force. However, the most important part about this is that this experiment demonstrated that through a prolonged culture period, the viability of this system from long mechanobiological studies is actually true. And also, it demonstrated its ability to do in situ testing without the perturbations that will arise from transferring the tissues to a conventional mechanical testing system. All in all, this system offers an advantage over the existing approaches by providing a novel window into the 3D mechanics of tissue remodeling in real time.